And from this point on, I'm recording the lesson and I will post it right after class is over. Okay, so first of all, let me, I am going to work off of some notes. So I'm going to pull that up real quick. And like I said, I will be working these out on the whiteboard. So let's go to 2A first. I'm just going to pick and choose a few things from each set of notes here. This is another thing that will be posted too before I forget. Since we're going to be working with conversions, I will post this instead of a PowerPoint. I will post this document because there's a lot of conversions that might be unfamiliar to people. For example, if you don't know how long a furlong is, or if you don't know how heavy a grain is, things like that. This will be posted. This is also available in your book. I got it right from your book. I copy and pasted it right from your book. So you can go to your ebook and look at that too. Okay, but here is the first thing we're going to start with. We're going to convert the distance of 9 feet to inches. Now, while I'm getting this all set up, let me just say I already know that all of you, definitely most of you, if not all of you, can do this conversion without me showing you either of these methods. Because feet and inches is something that's usually familiar to most people. I'm picking something that is this simple for a reason, because I want to show you these two methods to solve this. And that way, if you understand it with an easy problem, you do the same thing when the problem gets a little bit more challenging, and you should be okay. You can convert anything, no matter how complicated they get. Okay, so we're going to go with 9 feet, and we're going to change it to inches using these two different methods, the proportion method and the unit analysis method. So I'll go through each one of those separately here in just a second. So method 1 is to set up a proportion. So we talked about these last week. Now we're going to kind of extend this whole conversation that we were doing last week. So when you set proportions up, there are two ratios that are equal to one another. You can set proportions up in a bunch of different ways. There's about 6 different ways to set up every single proportion. What I do, and the way I'm going to continue to do it, just to be consistent and not confuse people, is I'm going to take the starting unit that I'm given, which in this case would be the 9 feet, and I'm going to create my first ratio by putting it over the thing that I'm being asked for, so the inches. Since I don't know how many inches there are, I'm going to make it X. So I go with the 2 units that are in the problem, the feet that I'm given and the inches that I want. Now, since it's a proportion and proportions are equal, I'm going to set this equal to another ratio and keep everything equal. The feet then has to stay in the top and the inches has to stay in the bottom. The numbers that are going to go over here are the conversion for inches to feet or feet to inches. There's 12 inches in 1 foot, and now I've got everything filled in. Now to solve a proportion, you cross multiply, so it's going to be x times 1 equals 9 times 12. X times 1 is just x, and 9 times 12 is 108. So since 108 was the x, that means that this is now 108 inches. And that one's done. Okay, so let me just wrap this up again. This is my way of doing it, by the way. I take the starting units, and set them equal to the conversion units. Okay, and again, if you don't know that there was 12 inches in a foot, it's on the paper that I'm going to post to Blackboard. This is something you should know by now, but if you didn't, that's okay. Any questions before I go through method 2? Okay, so let's go to the other one. Method 2 is called unit analysis, and it's set up in a very different way. Just depends on your personal preference which method you use. You can use either one. As you'll see, they'll both give you 108 for an answer for this. So here is how this one sets up. You'll take your starting unit and make a fraction out of it. So since 9 is a whole number, I'm going to put it over 1. I'm not going to label this. I'm just making a fraction. Okay, you're going to create a fraction from this starting unit. Okay, now this is going to require me to multiply. So if I'm multiplying now, my units that go next are going to be set up differently. The reason I'm going to do it this way, I'm multiplying, because I want to cancel the starting units. I don't want feet anymore. I wanted inches. In order to get rid of it then, I need to cancel it. So the feet have to be diagonal so that they will cancel. The new unit that you're converting to should remain in the top and nothing else cancels with it, and that's how you create this new unit. So the 12 inches and the 1 foot haven't changed, but they're still, the location that you place them in is a little bit different. So now I'm going to go straight across. 9 times 12 is 108. And 1 times 1 is just 1. The feet just canceled because they were diagonal. And inches is all that's left, so that gets retained in the answer now. And now to simplify this, this would just be 108. Okay, 2 different ways of doing it. Both give you the same answer. Just a personal preference, pretty much, with which method you're going to use. From this point on, I am not going to do each problem 2 times because that's just going to take too long. So what I'll do is I'll flip-flop. I'll do one problem with the first method, then I'll do the next problem with the second method, just to get you exposed to both. If you are going into any of the healthcare fields like nursing, LPN, even medical assisting and things like that, these are things you're going to have to do a lot. You have to do a lot of converting for your job, and depending on the instructor that you have, you might see them calculate them one way or the other. So it's another reason why I want to expose you to these 2 different methods. There's actually a lot more than just these 2, but these are the 2 most common. So we're just going to stick with that. All right. Any questions about the second method before I go to the next problem? Okay. So I'm going to go back to here, and I'm going to pull another problem out. Let's go with this one here. So it says, how many cubic feet of soil are needed to fill a planter that is 6 inches long by 4 inches wide by 10 inches tall? And they give you a picture here to try to visualize what you're trying to do here. So a couple things. First of all, I will be doing this with a proportion. And then I'll do the next one with the unit analysis method. but I'm gonna write down everything I have here. So they want cubic feet is the question. We have 6 inches long, 4 inches wide, and 10 inches tall. Okay, let's take a look. All right, so here's all the information they gave me. A couple things that I see right away is the question is asking for cubic feet. Cubic, when you see this, means cube or three-dimensional. That's indicating that they want you to calculate the volume of this planter. Also, I see that they're asking for feet. We have inches, so we'll need to convert. Okay, so there's two things going on here. First, we have to get something that is cubic, whatever. In this case, we're going to get cubic inches because we're measuring in inches. And then from there, we should be able to convert. So it's going to be a two-step process. So first, let's go with volume. Since that planter is rectangular, it's a rectangular prism, to find its volume, we're going to do 6 inches times 4 inches times 10 inches. So 6 times 4 is 24, and 24 times 10 is 240. But also, the labeling is extremely important in all of this. Inch times inch times inch, there's 3 of them, is inch cubed, which is commonly said as cubic inches. The 3 is read as cubic. So now we have something that is cubic. If the question said, how many cubic inches do you have? You'd be done. You have 240 cubic inches. But they didn't ask for that. They asked for cubic feet. So now we have to do another step. So next, we're going to convert the 240 cubic inches that we had to cubic feet. Okay, so if I do this with a proportion, as I mentioned before, I'm going to take my starting unit and put it over what I want. With this method, the proportion method, be very careful, they're two totally different things. With the proportion method, they get set equal to one another, which means that...
Hello, excuse me. I just joined. My name is Latia Jones. I'm sorry I'm late.
No problem. Next time, Latia, just sign in.
How do I do that?
You're going to just type your name over here in the chat box.
Okay, is it the little box with the words on the side?
Yep.
Okay, thank you. I'm sorry.
No problem. That's okay. Okay, so you're going to set them equal, which means that the inches that are cubed here have to stay up here. And the feet cubed, or the cubic feet, have to go in the bottom so that they are equal. If they're equal, they have to be at the same level. Okay, now here's another issue. Some people will automatically go to the 12 and the 1 because they know inches and feet. We're talking cubic inches and cubic feet now. This is not 12 and 1. Let me show you on the paper. where it is. It's right here. Let's see. I'm looking right here. You guys can see that. Go with that. Okay, there is the conversion to do this. 1 cubic foot is 1,728 cubic inches. Okay, so that is what we're going to use to plug this in. So the 1 goes with the cubic foot, and the 1728 goes with the cubic inch. Okay, I'm going to finish this, and then we're going to go back to where these numbers came from here in just a minute. So let's go back to this. To finish this up, I'm going to cross multiply. So 1728 times x. And it's equal to 240 times 1. 240 times 1 is just 240. Next, I need to divide. Which will cancel that over here, and then I'll have my x by itself. And then here, I'm just going to plug that in, and it's going to be a decimal. So let's see what we got. 240 divided by 1728 is giving me this repeating decimal. So I'm going to jot it down, and then let's talk about that too. Okay, so on my calculator, I can see that that 8 went on forever. This is a repeating decimal. Well, my answer is cubic feet. So if I needed an exact measurement, this would be fine. But if you actually had to buy something like this, you wouldn't go to the store and ask for this much soil. You would go back to fraction form, most likely. On my calculator, I just hit my SD button, and that'll change it back to fraction form. This is a more exact way of writing something like this. If the homework says to go ahead and round this, that's fine too. You could make it 0.14, something like that, depending on how they want it. So all of these are okay with me. Just pay attention to what my math lab wants and how they want you to enter the answer in. Okay, now, before I wrap this whole conversation up, I want to go back over to this conversion that we were looking at before. Let's say you couldn't find this information anywhere. Couple things. First of all, if you can't find it on the reference sheet that I'm going to post, and if you can't find it in your book, which there's a lot in the book, but there might not be all of them, then try Google. Just Google and see what you can find. So you have a couple different options as far as finding these conversions. I'm going to post a reference sheet for you. Check your ebook. Worst comes to worst, you can always Google and see what Google says. In a case like this, you can actually have figured this out yourself without any of these things. If you know that there is 1 foot, and if you know that 1 foot is equivalent to 12 inches, let me say it that way, then to get cubic feet and cubic inches, you can just cube both of these. What I mean by is 1 times 1 times 1. We need 3 of them. 1 times 1 times 1 is just 1. Feet times feet times feet is feet cubed. And then over here, 12 inches cubed is 12 times 12 times 12, which happens to be 1,728. And inch times inch times inch is cubic inches. Okay, so you could have found it yourself by just working this out on your own. Okay, but again, I'm not asking you to do that. I'm telling you you can use these three methods to find whatever you need. But in the future, you may not have every conversion available to you. You might not be able to Google. You might be working out maybe in a clinical and you have to figure it out yourself. That's how you could do it. Any questions so far? Okay. Heather, if it wants it a specific way, you have to put it in a specific way. I will not see it and change it. No problem. I'm not able to go through and see all of that stuff. So if it's marking you wrong, to know you're right, that's why you have 3 attempts at each question. Try it in a different way. Make sure you read the navy blue directions very carefully that are underneath each question. They'll tell you how to enter it in. So if they want fraction form, make sure you do fraction form. If they want a decimal rounded to the hundredth, then they want this. So just pay attention to the navy blue directions underneath. Okay. All right, well, let's go. Let's see here. Let's go down. Let's talk about the metric system. All right, so the metric system is, if you're not familiar with this, the metric system is the system that the majority of the entire world uses. We are one of the last countries left to adopt this system. We tried 2 years ago, and it really just never took. The metric system is all based on powers of 10. What I mean by that is 10, 100, 1,000, but also in fraction form, tenths, hundredths, thousandths. Everything is a power of 10, and that means we can move our decimal back and forth just to convert. You don't have to set up these fractions and cancel and cross multiply and do all this craziness. You can just literally just move your decimal back and forth and be done with it. But before we talk about all that, let's talk about how you move the decimal. So there's something called a metric prefix line, which I'm going to put up on the board here in just a second. The metric prefix line tells you how many spaces to move and in which direction to move your decimal. So I want to go through that here with you. So it looks like this. It's abbreviated with these letters: K, H, D, A. This space is for the base unit, which I'll come back to in a minute. D, C, and M. So the K represents the prefix kilo. Prefix means this will come before the root word. So it would be kilo something. H is hecto. DA stands for deca. This right here, the space, might as well talk about it right now, is reserved for the base unit. The base unit varies based on what you're measuring. So if you're measuring length, we normally use things like the foot, the inch, the mile. They measure with the base unit of the meter. Okay, so if this is the base unit, this is the root word. So then this would be kilometer, hectometer, decameter, and so on. That's if it's length. If they're measuring weight or mass, they use the gram. So again, this is the root word, this is the base unit. So it would be kilogram, hectogram, decagram, gram, and so on. And then if they're measuring liquid or volume, they use the liter, which is either a cursive L or an uppercase L, so it doesn't look like a 1. And this would be kiloliter, hectoliter, decaliter, and so on. There's others. There's lots of other base units other than the meter, the gram, and the liter. For example, the watt could be a base unit. It would be kilowatt if you're measuring power. If you've ever bought light bulbs, they're measured in things like that. And there's lots of others also besides that. These are the 3 main ones, and these are the main prefixes as well. So let me get back to this. D is a prefix deci, C is centi, and M is milli. Okay, these over here on the right are very, very small. These over here on the left are very large. Okay, let's do an example so I can show you how this all gets used. Also, hold on. This is a little saying to help you remember. If you can remember this little saying, you'll have the metric prefix line ready to go. This is a little different than what is up on the lecture. They have a different saying. This is the one that I know. But just to help you remember the order, because the order of these prefixes is what drives the whole process. So let's go and do an example of this here. How many milligrams are in 0.2 grams? Let's do that one. Okay, so you're starting with 0.2 grams, and they're asking you to change it to milligrams. Grams and milligrams both have that same root word at the end. That's how you know you can do this method. If you have gram in each of these, that means they're both metric. You're measuring weight. So we're going to start at the gram on the prefix line. Gram is a base unit, so you're starting right here. And you're going to move yourself to milligram. So you're going to move, in this case, 1, 2, 3 spaces to the right. What that means is move your decimal 3 times to the right. If you're starting here, you're going to go 3 times to the right. 1, 2, 3. Put it back here. Fill in with zeros, and now we've got the number 200. So 0.2 grams is equivalent to 200 milligrams then, all based on just moving decimals back and forth. The other thing I want to add on to this too, if moving decimals is something that confuses you, some people are not sure where they're supposed to put it. Do we put it between? Do we put it in the back? Where do you put it? Maybe try this instead. Every move to the right on this prefix line is like multiplying by 10. And every move to the left is like dividing by 10. So if we move 3 times to the right, we're multiplied by 10 3 times. So 10 times 10 times 10 is 1,000. So what we could have done instead would be 0.2 times 1,000. And that will give you 200 that way. Just a different way of thinking about it. You still use the metric prefix line to figure out what that would be, but instead of moving your decimal, you could just plug it into your calculator. All right. Let me do one more like that. Oops. Let's see here. I'll do this one here. 2759. Centimeters to meters. Okay. Again, before I get going, I need to make sure that I can do it this way. So I see centimeter and meter. They both have meter in them. That means they're metric. And as long as they're both metric, that's when I can move the decimal. If one of them is not metric, you can't do it this way. You'll have to go back to the proportion or the unit analysis method that I showed you earlier to do the feet and the inches. Okay, so having said all that, I'm going from centimeter to meter. So centimeter is here. I'm going back to the base unit, which is the meter. So 1, 2. 2 to the left, starting behind a 9, 2 to the left. That's it. And I'm done. Okay, any questions about the metric system? Okay. All right, Kelly, I don't know if you're still on the call or not. I see your message. I'm recording, so if you're missing anything, you can go back and watch it afterwards. All right, I'm going to switch gears. We don't have a ton of time left, so I'm going to start doing a few of those application problems. So we can get a few of those in. So this is the type of question that you'll see in chapter 2B, a little bit more involved types of questions. Let's try this one here. Okay, so you are planning to make pesto and you need to buy basil. At the grocery store, you can buy small containers of basil priced at $2.99 for each 2/3 of an ounce. And at the farmer's market, you can buy basil in bunches for $12 per pound. What's the better deal? So first, let me jot it all down. The grocery store sells it $2.99 for each 2/3 of an ounce. And at the farmer's market, you can buy it for $12 per pound. And they want to know the better deal. Okay, we've got quite a few that are very similar to this on your homework. So let's take a look. Strategy is going to essentially be the same. So a couple things I need to point out. If they are asking for the better deal, they want unit prices or unit cost. A unit cost is when you have the price divided by the size. And this is got a unit of 1. Okay, so it'll be like cost per 1 pound, cost per 1 ounce, cost per 1 anything. Ounce. Oh, I just said ounce. Anything. Whatever the price is divided by the size, and it has to be per 1. So let's take a look and see what we've got. We've got $2.99 for 2/3. 2/3 is not 1. And then we've got $12 per pound, which does mean 1. When you don't see a unit, that means there's a 1 there. So this is already a unit price or a unit cost. This one is not. So let's try to get this to a unit cost first. To do that, you divide. Okay, so we're going to take the price and divide it by the size. And that will give me the price per 1 instead of price per 2/3. I don't want that. Okay, so I'm going to plug it in. $2.99 divided by 2/3. Now, I am working with a scientific calculator that has a fraction button. I would highly suggest you use your fraction button as well. They all have one. You just have to learn which calculator you've got. On mine, my fraction button is this right here. It's got 2, it's hard to see it. It's got 2 little boxes. Something like that. And that way I can plug things in just the way I write them. I don't have to convert anything. I don't have to go to decimal form. I can just plug it in and it'll do the work for me. This that I'm using, by the way, this is my phone. This is an app that I downloaded. It's a free one called CalcES. If you want to look, try to find an app that has something like this, it would definitely help. Okay, so in the meantime, let me finish this up before I run out of time here. In the meantime, this is the answer I'm getting, 4.485. Since we're talking about money, I'm going to round that off and make it 4.49. So $4.49 per ounce, per 1 ounce. Okay, now I've got unit prices. I've got $4.49 per ounce, and I have $12 per pound. I still can't compare these now, though, because one of them is in pounds and one of them is in ounces. In order to compare and figure out what's the better deal, you need unit costs that are in the same size. So we either need to change our ounces to pounds or our pounds to ounces. Okay, that's what I'm trying to price compare. You can't compare this. This is apples to oranges. We need it to be apples to apples. So what I'm going to do is pick one and convert it to the other one. It's easier to change the 1 pound to its ounce equivalent because you can just go and look it up. This is just a conversion. There's 16 ounces in a pound. And I don't have to calculate anything then. I can just look it up. So here I have a new amount to compare. It's $4.49 per 1 ounce or $12 for 16 ounces. Still a little bit hard to compare because now I changed this and this is no longer a unit price. So if I divide it again, I can get it to a unit price. So I'll do 12 divided by 16, which is 0.0, It was 0.75, which means it's 75 cents per ounce. Okay, now I can compare this. I've got unit price per ounce versus price per ounce. Clearly, without even a question, this is the much better deal. It is so much cheaper. The problem is the way that they originally were advertising all of this stuff. Since everything was so different, we had money per 2/3 of an ounce and money per pound. Everything was different. It's hard to figure it out. Once you get this same unit, same unit, same unit, same unit, now it's easy to see. Okay, so to wrap this all up, if you have a question like this, and you have quite a few like this, you need unit costs. You're going to divide to get unit prices. Price divided by size. Money divided by size. That'll give you a unit price. And then if your labels don't match, you need to convert them so that they are the same. We did ounces to ounces, but we could have done pounds to pounds and compared it that way, and it still would have worked. Any questions about that? Okay. All right, let me pull out another one. Let's see how many more we can do. Okay. I'll just do one like that. Let's go to something a little bit different. Try something like this. Okay, here's another type of application that requires conversions. And again, you can do the conversions however you want. You can do them with proportions or with unit analysis. So here we go. A child weighing 15 kilograms has a bacterial ear infection. A physician orders treatment with amoxicillin at a dosage based on 30 milligrams per kilogram of body weight per day. And it's going to be divided into doses every 12 hours. Okay, and then the question was, how much amoxicillin? Every 12 hours. All right, let's take a look. We'll deal with part B in a minute. All right, this question's got a lot of information, so let's sort through it. The child weighed 15 kilograms. I'll just add this in here. The dosage information is that we're supposed to administer 30 milligrams per kilogram, so that's per one, per day, per each day, so that's per one. And then the doses are given every 12 hours. If they're given every 12 hours, that means you have to give it 2 times a day. All right, the question wants to know how much amoxicillin should we give every 12 hours. So how much amoxicillin, they're asking for how many milligrams do we give per dose. Okay, that's what the question's really asking then. Okay, let's take a look and see what we can do here. So first, let's figure out how much we have to give this child based on this dosage information. Child weighs 15 kilograms, so we're going to start with that. That's information that is presented to us that we cannot change. Child weighs 15 kilograms. What I'm going to do is I'm going to use the unit analysis method and set this up so that I can cancel the kilograms and get an answer in milligrams. That's what they're asking for. So I'm going to take this and multiply, putting kilograms down here. If that's the case, let's see here. That means that this will be up here. Oops. Just leave it like that for now. Okay, so I'm going to take 15 kilograms. I'm going to multiply it by something right here that will cancel my kilograms and leave me with milligrams. So the information that I have here is that it's 30 milligrams per kilogram. So 30 milligrams per 1 kilogram. So it's going to set up like this. And again, I'm doing this because I know that this method will cancel my kilograms if they're diagonal and will leave me with milligrams as an answer. So let's see what I get. 15 times 30 is 450. 1 times 1 is 1. So my answer is milligrams. Now, here's another thing we got to pull in. We had all this information connected to each other. 30 milligrams per kilogram, and this is per day. So this answer that I get is per day. That's not what the question wanted. They wanted milligrams, we got it, but they wanted per dose. We're not done yet. So now, if I'm going to give it 2 times a day, all I have to do is basically divide this by 2. Okay, and that's perfectly fine. What I'm going to show you is what this would look like if I set this up to cancel. So if I have 450 milligrams per day, what I need to do then is cancel the days and put those diagonal. If I can do that, then I can have what I need. I need it per dose. So there's 2 doses per day. So it looks like this, and this is how the math works out. As I said before, we know we have to divide by 2, but this is where the math will work itself out. So taking this straight across, it's 450 times 1, which is 450, and 1 times 2 is 2. My days cancel because they were diagonal, and now I've got this as milligrams per dose. So if I divide that to simplify, it'll come out to be 225 for 1. Okay. Questions at all? Okay. Let's take a look at that second part here. I think we'll have to wrap it up after that. All right, so part B says if the medicine is to be taken in a liquid suspension with concentration of 25 milligrams per 2 mLs, 2 milliliters, how much should the child take every 12 hours? So let me get rid of this old question here. and fix this a little bit. And then I'll explain, if you're not sure what you're reading there, I'll explain what is happening. I'm just jotting this all down. Bear with me 1 second. Okay, so basically what's happening here is this child is a young child, can't swallow a pill that's a 225 milligram pill. Just take it in one shot. Okay, so what they need to do is take that pill and crush it up and mix it with this liquid. Okay, so the concentration of the medicine is already given to us. We don't have to crush a pill. This is what we have. We need to take this and mix it up with that pink liquid that kids usually get, so that this child can drink it. Okay, that's basically what's happening. So the question wants to know how much.
Excuse me.
Yep.
Miss Walker, what time is class over? I'm sorry, this is my first day in class.
3:20.
Okay, thank you.
Hang on, every 12 hours. Okay, so let's go here. Here's what's happening. If we're going to give this concentration and we're going to mix it with some liquid that does not contain any medicine, we need to know how much we're going to give. Now they're asking for how many milliliters of this are we going to give to this child so that they get the correct dose that we figured out before. All right, so if that's what they want, and here's information on milliliters, this is what we need, we're going to have to cancel the milligrams to get this. Okay, and every 12 hours, again, is each dose. So we need milliliters per dose when we're done. All right, so here's what I'm going to do. I'm going to take what I know I have to give, the 225. You know what? No, I'm not going to. Let's not start with that. If we want milliliters per dose, let's take this one here. So we're gonna flip this upside down. So that we have milliliters first. And then I'll cancel by putting milligrams diagonal and the dosage at the bottom. I want it to be milliliters per dose when I'm done, and cancel these two. This setup should do it. So over here, I'm going to use the milligrams per dose that we figured out from the first part. So 225 milligrams per dose means per one dose. Then I'm going to go straight across. So 2 times 225 is 450. 25 times 1 is just 25. My milligrams just canceled. My milliliters are left in the top. My dose is left in the bottom. And we have it in the right form, milliliter per dose. Milliliter per dose is what the question wanted. So all I have to do here to finish this is just divide it. 450 divided by 25 is 18 milliliters per dose. So that's what you would measure out and then give to the child. All right, that is all we're going to have time for today. Do we have any more questions before I stop?
Can you explain the homework, please?
Sure. All right, so let's close this all out. Okay, so I'm back in Blackboard. Just to remind everybody here, go to Welcome, Start Here to find what your assignments are. So you're going to go to the tracking calendar, open it up. Here's what we did last week, and here is what we just did this week. Okay, so in order to get yourself caught up, you need to make sure that you have looked over for the classroom activities, the entire lecture, which is in Module 1. Classroom activities, both for this week, is the lecture for Module 1. So let me show you what I'm talking about real quick. Go to Modules, go down to Module 1, and view this lecture from start to finish. That is the classroom activities from last week and this week. That'll get you all caught up with that. Then my Math Lab homework is the Module 1 homework. It's the same one for this week and last week. Everything is due on the 6th. Let me highlight all that. My Math Lab homework is due on the 6th, which is next week. My Math Lab homework, same homework. You should be finishing it now. It is due on the 6th, the whole thing. To get to that, you have to go to Blackboard and click on My Math Lab and go down to the homework link. Okay, here is Module 1. That's the one you need to complete. Okay, now going back, you also have a quiz that you need to take. My Math Lab quiz is due next week. It is the same quiz from last week as this week. You have to complete the quiz. Okay, to get to it, you will go back to Blackboard, click on My Math Lab, and instead of going to the homework, go to the quizzes and tests. Here's the quiz that you have to take. It's only a couple questions long. It shouldn't take you too long. Okay, and then last but not least, make sure you have looked at the chapters in the textbook. Don't read it word for word. Just look it over because there's a lot of information in the textbook and those lectures that I was talking about that I don't have time to go over in class. You have to just skim it over and make sure you understand what they're talking about. There's a few formulas in there that we didn't talk about. That's all for next week. That's pretty much it. So once we are done, I'm going to stop recording right now, as a matter of fact.